Let's see the operations to be carried out in CYPE Connect to solve a connection between a beam and a column using a lateral plate. To do this, once the node has been created, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. This opens the connection window. In the Model tab, we must specify the operations needed to define the connection. In this case, we click on the lateral plate option to add an element with these characteristics. By keeping the operation selected, in the left-hand table we can configure its parameters using the options in the central panel. In the drop-down menus above, we select the section and the part of the section where the sheet is to be placed. In this example, the web of beam B1. Then we specify that it will be joined to column C1, and more specifically to the nearest face. Next, we define the material of the sheet. To do this, we click on the button on the right. In this case, we select S275 steel and click on Accept. In geometry, we define a thickness of 10 mm, a depth of 140, an overlap of 70, a spacing of 10, and a displacement in Y of 0. We can use the help available in the button at the top right of this section to guide us through the definition of these values. We also choose the position of the sheet, which can be on the front face as in this case, on the back face, or on both faces. Further on, we define the bolts that join the lateral plate to the beam. To define them manually, we click on Add to add them to the table and type in their X and Y coordinates in the units shown. Here we add 3 bolts that have an X coordinate of 0 and Y coordinates of 40, 0 and -40 mm. At the top of the table there is also a tool to generate bolts automatically if necessary. In the help image, the local axes of the board are shown, with the X-axis in red and the Y-axis in green. Furthermore, 2 rows and 3 columns of bolts are shown. Below, we define the type of bolt. We click on the button on the right and select the series ISO 4014 as well as a nominal diameter of 12, and then click on Accept. Further on, we specify the material of the bolt, which will be 10.9 steel, and then we click Accept again. We give a space of 2 mm. At the bottom, we can also reverse the direction of the bolts. Then, we define the welds by activating the corresponding checkbox. These correspond to the welds between the lateral plate and the column. In each section, the first drop-down menu shows several possibilities for defining the position of the weld, on the left side, on the right side, or on both sides, as in our case. In the second drop-down menu, we choose whether the welds are fillet welds, defined by the throat thickness or by the thickness of the side of the weld, or double bevel butt welds. In the third drop-down list, the shape of the weld surface is defined as not defined, flat, concave, convex, or with toes blended smoothly. In the fourth drop-down menu, we specify the place of execution, either on-site or at workshop. Here, we define fillet welds by throat thickness with a dimension of 4 mm. The parameters of the electrode, such as its reference and the resistance of the filler metal, can also be specified. Finally, we specify whether the welds have an initial or final displacement. From here, once the model is finished, we can continue to work by opening the Analysis tab to carry out the analysis of the connection.